When it is difficult to make physical measurements, heights and distances can be measured with the help of trigonometry. Let's consider an example. A girl is standing on the ground and looking at the top of a building. Observe that here a right-angled triangle ABC is formed. Now, the height of the building can be determined using trigonometric ratios. Line of sight. Line of sight is an imaginary line drawn from an observer's eye to the object viewed by the observer. Angle of elevation. The angle between the line of sight and the horizontal is known as the angle of elevation of an object if the object viewed by the observer is above the horizontal level. It is also called the angle of inclination. Let us assume an observer is looking at an object above the horizontal level. In this figure, QP is the line of sight. QX is equal to RS is the height of the observer's eye from the ground. PR plus RS is the height of the object from the ground. QR is equal to XS is the horizontal distance of the object from the observer's eye, and angle PQR is the angle of elevation or the angle of inclination. Let's look at the application of trigonometry in solving an everyday problem. A flagstaff is placed on the ground. The angle of elevation of the top of the flagstaff from a point on the ground which is 50 meters away from the foot of the flagstaff is 45 degrees. What is the height of the flagstaff? Let AC be a flagstaff standing on the ground, and B the point from which the observer is looking at the flagstaff. Now, angle B is the angle of elevation of the top of the flagstaff. So, in the right-angled triangle ABC, for angle B, perpendicular is equal to AC and base is equal to BC. Tan B is equal to perpendicular upon base. Tan B is equal to AC upon BC. Take it as equation 1. From the figure, angle B is equal to 45 degrees and BC is equal to 50. Put the above values in equation 1. Tan 45 degrees is equal to AC upon 50. 1 is equal to AC upon 50 because tan 45 degrees is equal to 1. AC is equal to 50. So, the height of the flagstaff is 50 meters. Tap the button to understand this better with an example. Fill in the blanks with the correct values. 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 If an object viewed by the observer is below the horizontal level, the angle between the line of sight and the horizontal is known as the angle of depression or angle of declination of the object. Let us assume an observer is looking at an object below the horizontal level. In the figure, angle BAC is the angle of depression or angle of declination. AC is the horizontal and AB is the line of sight. The angle of depression of a stone from the top of a building is 60 degrees. If the height of the building is 30 meters, find the horizontal distance between the stone and the foot of the building. Let LM be the building of height 30 meters. Let OLN be the angle of depression of the stone at point N from the top of the building. Now, in the right-angled triangle LMN for angle N, perpendicular is equal LM, base is equal to MN, and hypotenuse is equal to NL. So, from the trigonometric ratios, tan N is equal to perpendicular upon base. Thus, we can write tan N is equal to LM upon MN. From the figure angle, OLN is equal to angle N, which is equal to 60 degrees, and LM is equal to 30 meters. Now, on substituting the above values in equation 1, we get tan 60 degrees is equal to 30 upon MN. On solving, we get MN is equal to 10 square root 3. Therefore, the horizontal distance between the stone and the foot of the building is 10 square root 3 meters, which is approximately 17.32 meters. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic.